Alright, in this video I am going to introduce exponential functions, and I just want to review real quick the type of functions you already know about. So let's just start off with the most basic ones you probably learned in algebra. Linear functions take this form: y equals ax plus b, or you might see mx plus b. Right? So these are just like examples would be like y equals 5x or y equals 3x minus 7. Stuff like that. They just form straight lines, nothing too fancy there. Quadratic functions take this form where a, b, and c are all just real numbers. Okay? And so quadratic functions would look like parabolas. Okay. Cubic functions would just be the same thing, except we're just going to have more terms. So I'm just going to give you an example. Well, maybe I should write it out. Ax cubed plus bx squared plus cx plus d. And eventually we realize, we recognize a pattern where we're just going to get more and more terms, right? So that's where polynomial functions came in, and we studied that before, where polynomial functions, instead of just writing the actual numbers here, we ended up getting something fancy where we had a sub n times x to the n plus a sub 1 less than that one times x to the n minus 1, and we went on and on and on. And we would end with just some value out at the end. Okay? And so polynomial functions, we defined them, all of the coefficients had to be rational numbers, I believe. We talked about them being rational numbers. We also talked about rational functions, where rational functions just take the form like 1 over x is a rational function, right? So it's where the top, the numerator and the denominator are polynomials, okay? That's a rational function, just one fraction like that. If we could say y equals if we wanted, but both of those would have to be polynomial functions. And then we get to the exponential functions, and that's a little bit different. So we've dealt with a lot of different things happening with exponents. And here, the difference is the exponent is actually the variable x. So everything else, we had x, as just we're multiplying, and all of our exponents here, we're changing. Here, the exponent itself changes. And so I'll just go down here. In our textbook, it defines it as, I think it uses not y, but it uses f of x. I'll just use y. Y equals, it says c times a to the power of x. And I'm not sure why they used c. We've seen it like this: a times b to the power of x. At our school, we've been using a and b instead of c and a. So if you see it in your textbook, c is just your starting value, a is our multiplier in this example, whereas a is our starting value here and b is our multiplier. I'll try to use this in the future because I think people are more familiar with it. So a is what we're starting with and b is what we're multiplying times however many x's it says. So exponential functions grow a lot faster than linear functions. Linear functions is just going to form a straight line, and these are going to form some real crazy curves. And I put out a practice on that before, so hopefully you've seen that. If you wanted to, you could create a table of values to kind of see. So what you could do is you could say, okay, when x is what is the output? What is f of x? Right? And you could create a table of values for that in 0, 1, and that could help you see how a function will grow. Okay, you could do that with linear and compare it to the exponential. It should help, though, to know some laws of exponents. And so what are some of the laws of exponents? Laws of exponents are things like, what is the value of x to the third times x to the second? What does that equal? Well, it equals x to the fifth. Okay? The law of exponent, there's laws here, and what that means is, how do we get 5? Well, we added our exponents. So if we had this x to the a times x to the b, the law says to get our answer here, we would have to add a plus b. And there's a lot of different laws. We go through the subtraction one. When would we subtract? Well, we would subtract if it was like x to the third over x to the first. Well, how do I get our answer? It's x squared. we would do x to the 3 minus 1, which is x squared. Okay. We can continue on with laws of exponents, where one of them is what happens when it's x to the third power over x to the third power. Well, that's going to be 1, right? And if we followed this law, that would be 3 minus 3, which is 0. And that's actually one of the other properties that you want to know. X to the 0 power, anything to the 0 power is 1. So let's go back to this table. If we were filling out this table, and we plugged 0 into this arbitrary function, this exponential function here, with 0 here, b to the 0 power, that's what we would do first. B to the 0 power must be 1. So then it would be 1 times a. So our starting value will be a. That's an a right there, and that's that a. So that's where we will start on our graph, and that's going to be a y-intercept actually. All right. So that a value could be 1, it could be a fancy number, but we're going to study these exponential functions. Knowing some of the laws of exponents can certainly be helpful. And then it turns out exponential functions, and this isn't all of the things that you would learn in math, exponential functions turn out the inverse of them is going to be a logarithm. Okay? So we'll learn about logarithmic functions as well. But that's your intro.